Hello everyone, I hope you are doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is minimum multiplications to reach end, and it is a medium level problem. So the problem says that we have been given two integers start and end, and we have also been given an array of n numbers. Now what we can do at each step, we can take the current variable or the current integer and multiply it with any number in the array and then take the mod with 10 raised to the power 5, right? Now we are going to start from the start integer and we have to reach this end integer. This is our whole task, and we have to find the minimum number of steps in which end can be achieved. So for example, if you have a look at this particular test case, the start value is 3, right? Now if you multiply 3 with 2, it is going to be 6 and we have taken 1 steps. Now if you multiply 6 with 5, it is going to be 30 and we have taken 2 steps. And 30 is a desired end value. So that is why the total number of steps is 2. And if the answer does not exist, you have to print -1, right? So the time and space complexity of this particular problem is 10 raised to the power 5 and 10 raised to the power 5 as well for both time and space. So just for the idea, you can solve this problem with BFS. If you want to try, you can still try this problem with BFS. But first I'll try to give you a slight intuition why only BFS and why not any other technique. So let us discuss how we can solve this problem. Now a lot of these problems where you have to find the number of steps or where you have to find the number of transitions, right? The number of transitions you have to make to reach from the start state to the end state, right? So a lot of these problems are generally solved with either BFS or DP, right? So you can use any one of these methods to solve these problems. So let's say you were trying this problem with iterative DP, right? So let's say now if you try to form the states, obviously one of the states will be for the n elements and the other states will be for the 10 raised to the power 5 different values, right? So if you try to form this particular state, you will realize that there is one caveat with this particular approach, and that is, for example, your current value is j. You multiply it with the current element array of I and then you take its mod, right? Like this. So this will be the second state. But if you are taking the current element, let's say the I will remain same, right? Or the current position will remain same. Now you see that when the I remains same and this second value is changing, so in some cases the new value j dash might be bigger than j, and in some cases the value j dash might be smaller than j, right? So there is no fixed dependency, right? So there is one thing for sure, you cannot apply iterative DP at least. So as soon as I observed this particular thing, that the second part of the DP array does not have any fixed dependencies, right? Sometimes the new value that we get can be greater than j and sometimes it can be smaller than j. So whenever we encounter anomalies like these, we know for sure that iterative DP at least cannot be applied. So I thought like maybe we can also try doing BFS and let us see how it goes. So this is not a definite way of solving these kind of problems. I'm just telling you how I thought while solving this problem. So if I know that DP and BFS are two ways and I was trying to solve with iterative DP, I realized that this is not possible. So I tried to solve this problem with BFS. And for BFS, what they have said that the expected time complexity will be 10 raised to the power 5. I might be wrong on this particular thing, but I believe that the expected time complexity can never be this, because the time complexity of BFS is always V plus E. We can assume that the maximum number of states can be 10 raised to the power 5. But what about the edges? So they will be the number of states into the number of transitions we can make, right? So this will be 10 raised to the power 4. So I believe that this should be roughly the expected time complexity of this particular problem, right? For the space complexity is correct, because at max we will be having 10 raised to the power 5 elements or 10 raised to the power 5 states in our queue. But for the time complexity, if we have 10 raised to the power 5 states or vertices, then the number of edges will be, for each of these vertices we have 10 raised to the power 4 transitions. These are the number of elements given to us in the input array, right? So I believe that this should be the correct time complexity of this particular problem. Now how do we actually solve it with BFS? So what you can do is, since there are 10 raised to the power 5 different values, you can consider each of these values to be a separate node in our graph, right? From each of these nodes you can make n number of transitions, right? So first of all you can try to multiply it with ARR of 0, right? Then you can try to multiply it with ARR of 1 and then so on, right? So from each of these transitions you will get a new state, right? And again from here you can try to bring new transitions, and once you reach a node with your end value, That means you have found your correct answer and you can just return the distance of that particular node. Right, so you just had to apply a simple BFS and I believe you will be able to solve this particular problem. The only thing is observing why this problem cannot be solved with DP and what should be the correct time complexity of PFS as well. A lot of times you will only get the correct approach when you try to estimate what are the caveats or what are the disadvantages with other approaches. So I believe that was it for this video and let me show you my code. So you see what I've done is I created an integer n, so this will be the size of the array, and I created the mod value 10 to the power 5. Right, now I initialize my vector of distance with the size of mod and all values initialized to infinity. Right, so these will be the number of unique values that I can have in my graph, or these will be the number of nodes that I can have. Now I create my queue and I push this particular start element into my queue and I initialize my distance of start with 0. So if start is itself equals to end, that means I have to perform 0 steps and I can return 0. So this will act like a base condition. Now, while my queue is not empty, I'm just going to take my current node value and I'm just going to traverse through all the values in the array. So my child is going to be I into the current node value. So I is the current value or in the array, right? And I take its mod with this particular value. So if distance of child is greater than distance of node, I'm going to update its distance. And if this child becomes equal to the end node, I'm just going to directly return its distance. Now, if this does not happen, I'm just going to push this particular element into my queue, right? And after all the traverses has been done, if I do not find my desired state, I'm just going to return -1. So this would be the solution for this particular problem. Now let me just quickly submit this and show you that this particular code works. So you see it passes all the test cases and the solution is absolutely correct. I hope that you guys were able to understand the solution. If you guys did, consider dropping a like on this video and don't forget to share your thoughts in the comments because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you and it will be able to reach much more people like you who want to keep solving new problems. So I see a lot of people who watch these videos have not subscribed yet. In case you're one of them, then definitely consider subscribing. It's always free of cost and you can always unsubscribe if you don't find the videos interesting later. So share the channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.